This is a video about, in case you missed our session today, on how to do the assessment. I'm going to go through some of these problems. First, I want to point out that in your session notes, there is a PDF, and it has all the notes that we've used for, and walk you through some of that stuff. These notes on how to do zeros, holes, and vertical assessments are especially helpful, as well as how to find horizontal asymptotes. All right. Most of these problems can be solved. If they have an equal sign, most of these problems can be solved with your Mathway calculator. All right, so let's get to the first one. It says, which of these expressions is in simplest form? All right, simplest form means it can't be, that there's no more cancellation that can be done. And I think right here we can see on this one that you could cancel out the 2 on the bottom. All right, so that won't be our answer. This one we're not really sure about. This one, I see that we can cancel out an X. All right, and this one definitely does not have any cancellation that you can do. All right, so that's going to be our answer. There's no X plus 4 in the denominator, and those 2 expressions on the bottom are not in the numerator. All right, so that's going to be our answer. All right, these problems are not going to be, for the most part, exactly the same as the test. All right. On this one, we want to find does a vertical asymptote. So remember what a vertical asymptote is. Oops. All right, so this thing right here, this line is a vertical asymptote. All right, so that's our vertical asymptote. Notice that the graph cannot touch the vertical asymptote. All right, and also notice that this vertical asymptote goes through x equals 3. All right, so we were looking for x equals 3. Well, definitely G goes through x equals 3. Now let's find x equals 4. Here's our x's, x equals 3. And there's x equals 3 in our table. All right, notice that it has a value here. All right, so this vertical asymptote at x equals 3 will not have any, notice it does not have any g of x values. So this definitely means this is not a vertical asymptote because it wouldn't have a value there. All right, so only G is going to work on this one. All right, so which of these functions has a hole at x equals 2? Let's look at, you look at your notes, or you can look at this little handy thing here. Holes are expressions that cancel out, right? So we can see that this is a hole in red, and it's because the numerator and denominator had the same expression and it canceled out. All right, so if we look here, is there anything to cancel out here? No. All right, so that can't be right. What about here? X does not cancel into x plus 2. All right, but here we have x minus 2 on the top and the bottom. All right, and so x minus 2 equals 0, and so the whole is going to be at the opposite sign. All right, so opposite sign. All right, because we want to know what will make that a 0. Well, 2 will make it a 0. 2 minus 2 is 0. All right, so there's our answer. There's this function right here has a hole. at x minus 2. All right, calculate the sum. Any of these where it says calculate the sum or calculate the difference, any of those, you can use your Mathway calculator. I am not going to do every single one of these, but I'm just showing the Mathway calculator. So if I say you can do this one with your Mathway calculator, I'm probably not going to actually go through and do the whole thing. I will on this one to give it as an example. Oops, really bad example. Okay, and then usually when you put something in like this, the Mathway calculator asks you a question like, what do you want to do? Well, this is calculate the sum, which is adding, right? So I'm going to click add on that. And it says my answer is 4x plus 9. Now I notice that their answer is not the same, but I notice that all of these have x squared plus 5x plus 6 in the denominator. And I'm going to put 4x plus 9 because that matches my answer over here. I don't like that. All right, so this is another one you can definitely put in your Mathway calculator. You hit this just to make sure you know what key I'm hitting. All right, this key right here will give you a radical so that you can put the values in. Okay, so that's what I did. And then under the radical, I'm going to put 2x minus 4. And I have to get out from under the radical, and then I say equals 16. And I hit calculate, and gives me my answer of 130. All right, so I'm going to simplify the answer this. All right, this one you can definitely put in your calculator, your Mathway calculator, and anything that has an equal sign, you should be able to put in your Mathway calculator. All right, this one, how many vertical asymptotes are in this picture, this function? All right, so if we go back to either our notes here, all right, so our notes have, what is a vertical asymptote? A vertical asymptote, okay, is a function that's not canceled out in the denominator. All right, you want to take a screenshot of my notes here. This would be like notes you took in your notebook. All right, it says a vertical asymptote over here in blue, right here. All right, it says a vertical asymptote. Expressions in the denominator that do not cancel. All right, expressions in the denominator that do not cancel. All right, so I notice there's an x plus 3 in the numerator. That cancels out. We can't cancel out x plus 2, and we can't cancel out x minus 3. So that means there are 2 vertical asymptotes. All right, simplify this expression. You could put this expression in your calculator, your Mathway calculator. You can also just do it straight away. It's pretty simple. To simplify, we cancel things out. All right, and so that's the only thing that's going to be left here is x times x plus 3 and x minus 1, and that's what you put into your answer. All right. So we're going to go on to the next one. So I said I'm not going to put all the answers in on these. Okay, the same thing here. You can put that in your Mathway calculator, or you can just look at it and say, well, I see that these x's cancel out, so the only thing left is x plus 5. and that's going to be my answer. All right, here we have show your answer in factored form. All right, so this is also can be put in your Mathway calculator. I'm not going to do all the Mathway calculator answers, but put that in your Mathway calculator, it will do the subtraction. Put this in your Mathway calculator, and this is a times. Put this in your Mathway calculator with a divide sign. Put this in your Mathway calculator, x over 4 equals x plus 2 over 2. Same with this one, put that in your Mathway calculator. Put this one in your Mathway calculator. Put this one in your Mathway calculator. All right, now we get to write an equation with a hole at x equals 6 and a vertical asymptote at x equals -5 and at least one zero. All right, so let's go back and look at my definitions here. Okay, so a hole is something that cancels out. All right, a hole is something that cancels out. So that means the expression has to be in the numerator and the denominator. All right, and it's always going to be the opposite value. All right, so if the whole is at x equals 4, the expression is x minus 4, the opposite sign. All right, and so if we want a whole at x equals 6, all right, the opposite sign is x minus 6. And that's going to be in the numerator and the denominator. All right, so I have to have an x minus 6. All right, so that's my whole, so I got that. Now it says a vertical asymptote of -5. All right, so vertical asymptotes are in the denominator, right, and they're not canceled out, so they're by themselves. All right, and this was x minus 5, so the vertical asymptote is actually 5, but our expression is x minus 5, the opposite sign. Okay, and this one, our vertical asymptote is x minus 5, so our expression is going to be x plus 5, the opposite sign, and we're going to put that in the denominator. And then it says at least one zero. All right, so what's a zero? A zero is an expression in the numerator that is not canceled. In this case, it's x plus 3. It could be anything. All right, and this doesn't give us any special numbers, so we'll just put x plus 3. We could have put x plus 1 or x by itself, any of those things. All right, and so that's going to be your answer. Delta Math will not grade that. This is teacher graded because there can be lots of different answers. So once you put it in, so let's put that in over here. X minus 6 times x plus 3 over x minus 6 and x plus 5. Okay, and so I'm going to submit that as an answer and say yes. Okay, and notice it didn't give me a check one way or the other because the teacher has, I have to grade that when you turn that in. All right, these next 3 problems, you have to identify quite a few things. These are important problems. Each one of them is worth 5 points, and you have to fill in the blanks down here. All right, now, so I'm going to go through these problems, not each problem by itself, but each section of each problem, so that we have to understand horizontal asymptotes. Notice that is the first thing that is asked for here is a horizontal asymptote. All right. Well, what's a horizontal asymptote? You might remember a horizontal asymptote. You tell what a horizontal asymptote is by looking only at the highest, normally the first two terms in the numerator and the denominator. So I don't really care about all of this over here. I'm only looking at that. All right, so there's three cases. All right, either the numerator is higher, or the numerator is, or the denominator is higher, or they're the same. All right, so three cases. So numerator is higher, so 3 is greater than 2. Denominator is higher, 2 is less than 3, or they're the same. These both are x squared. All right, in the case where the denominator is lower, so this first case where the numerator is higher, there's no horizontal asymptote. All right, in the case where the denominator is higher, so this is x2 over x3, all right, in that case, the horizontal asymptote is y equals 0. And in the case where they're both the same, x squareds, you cancel out the x squareds, and whatever you're left with, in this case 3 and 2, that's going to be your horizontal asymptote. All right, so let's look at our first problem. And our first problem, all we're looking at is the first two. All right, all we're looking at is, for our horizontal asymptote, is the first two values, all right, which is x2, x to the second power on top, and x to the third power on the bottom. All right, if I go over here, here's my example, x squared over x to the third power. It says y is equal to 0. All right, so that's going to be my answer, y is equal to 0. All right, next it says, what's the whole? All right, and so remember a whole, this is not going to let me go down, but a whole is where you can cancel out, all right, and so we can cancel out these 5s, all right, so our whole was x plus 5, and so remember it's going to be the opposite, so the oppo, so it's going to be x equals minus 5, the opposite of our expression. All right, so that's going to be a minus 5. Zeros are in the numerator and not canceled. So in the numerator, I see x, that my 0 is x minus 3. All right, and so the opposite of that, my x is going to be x equals 3, positive 3. So I have a 3 there. My vertical asymptotes, I have 2 of them. All right, so my vertical asymptote, I have an x, all right, and x is going to equal 0. And then I have x plus 4. In that case, my x is going to be negative 4. All right, so I have 0 and negative 4. All right, now the last thing is I have to match the graph. Okay, so which one of these graphs is this going to be? Well, the easiest thing to tell where is on the graph is if there's a hole. All right, this graph has a hole. Oh, good, I can make this bigger. All right, this graph has a hole, and the hole is at, so this is 1, 2, 2, 3, 4, negative 5. So this is negative 5. So there's a hole at negative 5 there. Let's look at this other graph. This one has a hole right here, at negative 2. And then our other graph doesn't have a hole at all. So since we have a hole at negative 5, all right, and this graph has a hole at negative 5, our answer here is going to be B. All right, and that's how we go through each one. All right, so I'm going to do one more example. So I'll go over here, I'll go to, all right, so the first thing we can do on this one, the first thing we do this one is look for the horizontal asymptote. All right, now we have the numerator is higher. All right, so the 3 is greater than the 2. All right, and so if we go back and look at our notes here, it's not going to let me go back. All right, but let's remember that. Okay, the 3 is higher. Okay, so when the numerator is higher, there is no horizontal asymptote. All right, and over here it says answer none. All right, so it says if they don't apply, answer none. All right, so we're going to say none for this, y equals none. Okay, a whole is something that cancels out. All right, so there's our whole. So our whole is x plus 2. So that's going to be x equals -2, the opposite sign. All right, so that's -2. Zeros are what's in the numerator. And we have an x, so our zeros, we have 2 zeros. You can tell that by the answer too, because the answer is asking you for 2 zeros. All right, so it's asking you for 2 zeros. All right, so 1 0 is x, so you have x equals 0, that's right here. And the other one is x minus 3. And for that one, we're going to have the opposite sign, so it would be a 3. All right, so our answers here are going to be 0 and 3. I'm going to put them over here, so I'm going to have space over here. All right, so this was none. None. And we said this was -2. And our zeros, one of them is at 0, and the other one's at 3. All right, and then vertical asymptote is in the denominator, and that's x equals x minus 1. So the vertical asymptote is going to be opposite of that, which is 1. All right, and we have to match the graph. All right, so let's see where our whole was at -2. Our whole is at -2, and C has a graph at -2. So we're going to put in C there. All right. Okay, so that's how you do, and that's how you do the next one as well. Good luck on the test, and remember, come to the session where we're having the test, and I will be happy to answer your questions about how to be successful on the test.